Now, today the topic is spline interpolation. Spline interpolation and cubic splines. Spline interpolation and cubic splines. See, what is the definition of spline? Let the given interval closed AB be subdivided into n subintervals. What are the subintervals? x0 comma x1, x1 comma x2, and so on. Lastly, xn minus 1 comma xn. N subintervals with how many points? N plus 1 data points, where a equal to x0 is less than x1, less than x2, less than, and so on, less than xn, that is equal to b. Okay, and the points x0, x1, and so on, xn are called nodal points, or simply called nodes, or one can write knots or grid points, or mesh points, okay. And the points x1, x2, and so on, xn minus 1, okay, are called x1, x2, xn minus 1 are called, what are these points? x0 is not there, xn is not there, intermediate points. So these are called internal nodes. So this is the first division. The interval closed AB is divided into n subintervals with how many points? x0 to xn means n plus 1 data points. And these data points are called knots, nodes, grid points, or mesh points. And this x1 to xn minus 1 intermediate points are called internal nodes. Now see the definition of spline function. First, spline function. What is the spline function definition? A spline function of degree n. What is the polynomial spline? It is a polynomial of degree n with nodes x0, x1, and so on, xn is a function capital F of x, satisfying the conditions. What are the conditions? See, the conditions are, the first one, capital F of xi is equal to small f of xi. This is true for I equal to 0, 1, 2, and so on n. What is the meaning of this? Small f of xi is original function, and capital F of xi is approximate function, nothing but interpolation function. This is the first condition. And the second condition is, on each subinterval, what are the subintervals? General notation, xi minus 1 to xi, for I equal to, this is 1 to n, capital F of x is a polynomial of degree n. What is the capital F of x? It is a polynomial of degree n. First condition, interpolatory conditions, capital F, P of xi equal to f of xi, like that. In place of p, we are considering the function capital F. And second condition is on each subinterval x0, x1, x1, x2, xn minus 1, xi. In general, the notation for subinterval is xi minus 1 to xi for I equal to 1 to n. On each subinterval, this capital F of xi is polynomial of degree n. Polynomial of degree n. And third condition is the function capital F of x and its first n minus 1 and its first n minus 1 derivatives are continuous on closed AB, that is the meaning. What is the meaning? F of x, f dash x, double derivative f double dash x, and so on. What is the last one? N minus 1th derivative are continuous on the domain, on the given domain a comma b. Then function f of x is called what? Spline function. So spline function definition, it is a function satisfying interpolatory conditions, first one. Second one, on each subinterval it must be a polynomial of degree n. And third condition, if it is a polynomial of degree n, then its n minus 1 derivatives are continuous. Now what is from, therefore, the cubic spline? Let us see. Therefore, this is spline definition, spline of degree n. Okay, just let me write. This is the spline definition of degree n. Therefore, a cubic spline. Now, a cubic spline means third degree. Now, what is n value? 3 here. A cubic spline has the following properties. Cubic spline has the following properties. What are the properties? As usual, same. First condition is what? Capital F of xi is equal to small f of xi for all I equal to 0, 1, 2 and so on n. What are these conditions? I already told you. Interpolatory conditions. And the second condition is what? On each subinterval, what is the subinterval? Xi minus 1 comma xi, where I lies between 1 and n inclusive. F of x is what? Nth degree polynomial in this definition. Now what is this? F of x is third degree, nothing but cubic polynomial. Third degree, in brackets, cubic, third degree polynomial. And since it is cubic polynomial, how many derivatives are continuous? Nth degree polynomial, then n minus 1th degree up to n minus 1th degree. Now third degree polynomial means the function, it's a first derivative and it's a second derivative are continuous in interval a comma b, This is open a comma b. Okay, this is cubic spline definition. Third degree polynomial. Spline means what? Not only the function is continuous, but its derivatives also continuous. That is the meaning of spline. Now, to derive the cubic spline, let us see what is the derivation. First, let cubic spline now. So let the function f of x be, that is interpolation pi of x, interpolating polynomial pi of x is ai x cube plus bi x square plus ci x plus di. On what interval? On interval, remember this, xi minus 1 comma xi interval. On the interval xi minus 1 comma xi interval, and again the polynomial f of x, but what is this one? I plus 1. If it is I plus 1, what is this? Becomes ai plus 1 x cube, bi plus 1 x square, ci plus 1 x plus d I plus 1. On what interval now this is? Xi comma xi plus 1. Xi comma xi plus 1. Both are same polynomials, but the intervals are different. One is xi minus 1 to xi. Another one is defined in xi to xi plus 1. Now, on each subinterval, on each interval, we have how many unknowns? We have ai, bi, ci, di. We have 4 unknowns, right? We have 4 unknowns: ai, bi, ci, and di for I equal to 1 to n. For I equal to 1 to n. Therefore, the total number of unknowns how much? Therefore, the total number of unknowns. Therefore, the total number of unknowns is how much? Here there are 1 to n means what? N. And here how many unknowns? 1, 2, 3, 4. 4 n unknowns are there totally. Okay. Now this is important. Continuity of the function f of x, f dash x, and f double dash x on the interval open AB implies the following. Open AB implies the following. First we will see all the conditions. Okay, what is the first condition? The first condition is continuity of f of x, capital F of x. What is the continuity condition? First one, on how many intervals we have considered? One is xi minus 1 to xi, another one is xi to xi plus 1. So on xi minus 1 comma xi, what is pi of xi? Pi of xi is equal to ai xi cube bi xi square ci xi plus di. Next one, on what is the next interval? Xi to xi plus 1. Xi to xi plus 1. What is this? Pi plus 1. Pi plus 1 of xi only, the point. I will explain the concept here. What is this interval is here? This is xi minus 1. This is xi and this is xi plus 1, right? And what is the first interval? This is the first interval. And next interval is again what? xi2. So what is the common point for these two subintervals? xi. That is why we have considered the continuity condition at xi for polynomial pix here and the polynomial pi plus 1x here. So both must be continuous at what point? For continuity xi, both polynomials must be same. So pi plus 1 of xi equal to, what is this? ai plus 1 of xi cube bi plus 1 xi square ci plus 1 xi plus di plus 1. These are the continuity conditions of f of x. Okay, take these conditions as 1. Next one, the second one is continuity of f dash x. Continuity of f dash x. Again same logic. What is continuity of f dash x? The meaning is what? Pi dash of xi must be equal to pi plus 1 dash of xi. And what is pi dash of xi? First one, if I take the derivatives of the polynomial pi of xi, what is this? 3ai xi square plus 2bi xi plus ci. This is the derivative of pi of xi, first derivative. Same logic for I plus 1 xi, take the derivative, you will get 3ai plus 1. That's it. I plus 1 xi square plus 2bi plus 1 xi plus ci plus 1. Ci plus 1. This is for 1 to n minus 1. This is for 1 to n minus 1. Second condition and second equation. Third condition is continuity of f double dash x. What is the meaning of this? P double dash of I xi equal to P double dash I plus 1 xi. So one more derivative for equation 2 gives what? 6ai xi plus 2bi, isn't it right? 2bi equal to 6ai plus 1 xi plus 2bi plus 1. This is equation 3. This is also for what? I equal to 1 to n minus 1. 1 to n minus 1, right? And at the endpoints, what are the endpoints? x0 comma xn. This is what? From 1 to n minus 1 only. All I is from 1 to n minus 1. So 0 and n are excluded in all these three equations. So at the endpoints x0 comma xn, we have the interpolatory conditions. We have the interpolatory conditions. We have the interpolatory conditions. What is that? Function at x0 is equal to a1 x0 cube plus b1 x0 square plus c1 x0 plus d1. Okay, this is from how you will write this one. This is from what? P I plus 1 of xi, from pi plus 1 of xi expression. Okay, I plus 1, that is why we are getting ones here, right? Remember this. Next one, why? Because x0 is what point? This is x0 and this is what? Xn. X0 means what? We have to move towards this point. So I will take I plus 1 condition. So right hand side limit I will consider moving towards right side. So I will consider I plus 1. And next one is, and what is the last one? F of xn. For this I have to consider what? Moving towards this side, not beyond xn. So less than this side means I have to consider what polynomial? This is, I will write, this is a n x n cube plus b n x n square plus c n x n plus dn. This is from what polynomial? Pi of x expression. Pi of expression. Why I am using this? Because I have to get towards this side, not xn plus 1 side. So let us use pix. Okay, these are the conditions, and take these two conditions as equation 4. Now total, so we have 1 to n minus 1 means what? N minus 1. So we have 2n minus 1 equations. 2n minus 1 equations from equation 1. What is equation 1 gives? In two intervals it is given. So n minus 1, 2n minus 1 equations. And next one is what? N minus 1 equations from equation 2. Okay, and n minus 1 equations, derivative conditions, n minus 1 equations from equation 3, right? And two equations from equation 4. That is, we have a total of how many equations? This is totally, add this 2n minus 1, 3n minus 1, 4n minus 1, and this is plus 2. So totally we have 4n minus 2 equations. And total number of unknowns 4n. So we need 2 more equations. To obtain cubic polynomial. Uniquely. Now for this we shall consider, to get these two conditions, for this we shall consider the case of natural spline, means general polynomial, in which natural spline means just a polynomial in which we set two conditions. We set two conditions as f double dash of x naught is 0 and f double dash of xn equal to 0. So double derivatives at endpoints x naught and xn equal to 0. Now these are the conditions. Okay, now let us derive a simple method. These are all the conditions. Okay, now let us derive a simple method to determine cubic spline. Let us see cubic spline. Okay, there are so many derivations, but I am giving the easiest derivation. Now cubic spline derivation. See, from the definition of spline, the spline is what? The spline is a piecewise continuous polynomial. Spline is what? Piecewise continuous polynomial. Hence, piecewise continuous cubic polynomial. What is this polynomial? Spline cubic polynomial. For cubic polynomial, what is f double dash x? Second derivative is what? Linear. That means straight line. F double dash x is linear function. F double dash x is linear function of x in all intervals. In all the subintervals or intervals. Okay, so consider the interval. So consider the interval xi minus 1 comma xi. Consider the interval xi minus 1 comma xi using Lagrange's interpolation. Linear. Okay, only 2 points are here. Okay, Lagrange's interpolation. In this interval f double dash x can be written as now what is the point? What are the points? Xi minus 1 xi, and what are the function values? Fi minus 1 fi. So what is the polynomial here? One can write the polynomial using Lagrange's interpolation for f double dash. Now this is my function, f double dash x is my function. So first delete the difference x minus xi minus 1, write this one and replace x by xi minus 1, and the function value, what is the function? F double dash at I minus 1, right? Plus. Now delete the difference x minus xi and write the other difference and replace x by xi. Okay, and the function at what point? Xi. The function at what point? Xi. So make the denominator, this denominator unique, same denominator. Let us write this as f double dash of x equal to, take minus common in numerator, xi minus x, xi minus xi minus 1, f double dash xi minus 1 plus x minus xi minus 1 by xi minus xi minus 1 f double dash xi. Okay, take this as equation 1. Now denote the double derivative has some notation. F double dash of xi minus 1 equal to notation mi minus 1, and f double dash of xi equal to mi Okay, now integrating equation 1 with respect to x. With respect to x, we get, what is equation 1? F double dash x. Okay, shall I write one more time? Okay, no need. F double, already equation 1 is there. For f double dash x, one integration is gives what? F dash x. Okay, and the integration of the next part, the total you can do is a simple integration with respect to x only, by 2 into xi minus 1 into f double dash of xi minus 1 notation. Now this becomes x minus xi minus 1 whole square by 2 into xi minus xi minus 1. This is mi plus a constant a. This is equation 2, integrating constant a, right? Integrating 2 again, integrating equation 2 again with respect to x, we get f dash x integration f of x. Again one more integration is what? Whole cube you will get here. So xi minus x whole cube by 3 into 2, this becomes 6. xi minus 1. This mi minus 1 is constant. And coming to here also, xi minus 1 whole cube by 3 into 2, 6. xi minus 1. This is mi plus ax plus b. This is equation 3, where a and b are integrating constants, where a, b are arbitrary constants. And b are arbitrary constants to be determined by using the conditions A and B are integrating constants, and they are determined by using the conditions, interpolatory conditions we have to use. What are those? F xi minus 1 equal to f xi minus 1 small, and another one is f xi equal to f of xi. These are the two conditions, together equation 4. Now denote xi minus xi minus 1, the denominator term, this as hi, and f of xi minus 1 as fi minus 1, and f of xi as fi. Okay, here hi is the length of the interval, length of the interval xi minus 1 comma xi minus 1 comma xi. Now to ease the computation, that is to make computation simpler, to ease the computations, we write a equal to d minus c and b equal to c into xi minus d into xi minus 1, such so that these two are assumptions. Remember these two, a equal to d minus c and b equal to this, so that this ax plus b becomes, what is ax plus b now? In place of a, write d minus c x, right, plus b c xi minus d xi minus 1. This implies ax plus b becomes what? Let us take c common. If I take c common, you will get xi minus x. If I take d common, this is x minus xi minus 1, x minus xi minus 1. That is, we write equation number 3. We write equation 3 as, what is my f of x now? This f of x equal to, the numerator is xi minus x whole cube by 6 into that xi minus 1, that is hi, 6 hi mi minus 1 plus x minus xi minus 1 whole cube by same, this is also 6 hi mi, and ax plus b. What is ax plus b now? Plus c into xi minus x plus d into x minus xi minus 1. This is 1 2 3 4. This is equation 5. You remember this equation 5 is very important. Now using the condition, the first continuity condition, fxi minus 1 equal to fxi minus 1 equal to fi minus 1, we get equation 5 implies, in equation 5 put xi minus 1 at x equal to xi minus 1. Equation 5 becomes, this is small fi minus 1, this is xi minus x, in place of x, xi minus 1, this is whole cube by 6 hi mi minus 1 plus, the next term will be 0, so the remaining part I am writing after substitution, xi minus xi minus 1. So this is equal to what? This is h, so hi cube by 6 hi mi minus 1 plus c hi. This is the value of fi minus 1. From this, what is the value of c? Get the value of c. C equal to 1 by hi fi minus 1 minus hi square by 6 mi minus 1. This is the value of c. Now let us use another condition. At x equal to xi, equation 5 implies, this is fi. Okay, this is fi, means what? Let us write, and this one, at x equal to xi, using the condition capital F of xi equal to small f of xi, interpolatory condition. This is fi. Equation 5 becomes fi equal to xi minus xi minus 1 whole cube by 6 hi mi. First term will be 0, second term will be there in equation 5, and c term will be 0 and d term will be there, xi minus 1. So this is equal to what? hi cube by 6 hi mi plus dhi. Okay, from this the value of d is 1 by hi fi minus hi square by 6 mi. This is the value of d. Now substituting c and d values in equation 6, we obtain the spline in the interval. What is the interval? We have considered xi minus 1 to xi as f I of x equal to 1 by 6 hi 1 by 6 hi xi minus x whole cube mi minus 1 plus 1 by 6 hi x minus xi minus 1 whole cube mi, okay, plus now c value x minus x, and what is the c value? By hi fi minus 1 minus hi square by 6 mi minus 1. Next, x minus xi minus 1, the d value hi fi minus hi square by 6 mi. This is equation 7. You have to remember, this is important. Is the spline, is the cubic spline, is the cubic spline expression, is the cubic spline expression. You have to remember, and note that in this one, in this cubic polynomial, till what are the unknowns? Note that the spline second derivatives, the spline second derivatives, what are the second derivatives? mi minus 1, f double dash I minus 1, mi f double dash I are unknowns, and are to be determined, okay. Now to get these mi minus 1 mi values, we will use the continuity conditions, okay. Now to determine mi minus 1 mi constants, setting I equal to I plus 1 in equation 7, we get the spline, valid in the interval, what is interval now? Becomes xi minus 1 to xi becomes xi to xi plus 1, as in equation 7 just replace I by I plus 1. This is equal to 1 by 6 hi plus 1 xi plus 1 minus x whole cube mi plus 1 by 6 hi plus 1 x minus xi whole cube mi plus 1 plus, I am writing here, xi minus 1 xi plus 1 minus x by hi plus 1, this is fi minus hi plus 1 square by 6 mi plus x minus xi by hi plus 1 fi plus 1 minus hi plus 1 square by 6 mi plus 1 by mi plus 1, equation 8. Here, where what is meant by hi plus 1? It is the length of the interval xi to xi plus 1, okay. Now differentiating 7 and 8, we get both equation 7 and 8. Let us differentiate f I dash x, seventh equation equal to 1 by 6 hi, I can take common in the first two terms, so minus 3 into xi minus x whole square mi minus 1 plus 3 into x minus xi minus 1 whole square mi, 1 by 6 hi common, minus 1 by hi fi minus 1 minus hi square by 6 mi minus 1, okay. X derivative 1, and next term derivative is 1 by hi fi minus, these terms are constants, x derivative 1. Okay, this is equation 9. And another one, 8 implies, what is 8? fi plus 1 dash x equal to 1 by 6 hi plus 1 is common in the first two terms, minus 3 into xi plus 1 minus x whole square mi plus 3 into x minus xi whole square mi plus 1, first two terms, minus 1 by hi plus 1 fi minus hi plus 1 square by 6 mi. This is x derivative 1, the remaining quotient as usual. Here also x derivative 1, the remaining quotient is fi plus 1 minus hi plus 1 square by 6 mi plus 1. You have to practice this actually. Okay, remember this equation 10, this is. Okay, and the first one is valid in the interval, and this is valid in what interval? Valid in what interval? This is xi to xi plus 1. Okay, 10 is valid in, and 9 is valid in what interval? Xi minus 1 to xi. So in these two intervals, what is the common point? I already told you, this is xi minus 1, this is xi, and this is xi plus 1. This is the interval and this is the another interval. So common point is what? Xi is the common point. Xi is the common point, this xi. Okay, now we require that the derivative, first derivative continuity using the first derivative continuity condition, first derivative continuity condition, we have the left and right hand and right hand derivatives of f dash x at x equal to xi. That means in this okay, let me write, must be equal. That is the meaning of continuity. That is, here what? This is my interval xi minus 1, this is xi, and this is xi plus 1. So first derivative continuity means this is left derivative and this is right derivative at a xi, both must be same. Okay, that is limit fi dash of xi minus epsilon as epsilon tends to 0 must be equal to continuity condition, just in a different manner, f dash of I plus 1 xi plus epsilon. Indirectly I'm writing that is fi dash of xi is equal to fi plus 1 dash of xi. Okay, at the point xi, fi and fi plus 1 both are equal. Therefore, using equation 9 and 10, we obtain after calculation and substituting everything, you will get hi by 2 mi minus 1 by hi fi minus 1 plus hi by 6 mi minus 1 plus 1 by hi fi minus hi by 6 mi equal to minus hi plus 1 by 2 mi minus 1 by hi plus 1 fi plus hi plus 1 by 6 mi plus 1 by hi plus 1 fi plus 1 minus hi plus 1 by 6 mi plus 1. This gives hi by 6 mi minus 1 plus 1 by 3 hi plus hi plus 1 mi plus hi plus 1 by 6 mi plus 1 equal to 1 by hi plus 1 fi plus 1 minus fi minus 1 by hi fi minus fi minus 1. This is for I equal to 1, 2 up to n minus 1. 1, 2 up to n minus 1. This is equation 11. This is equation 11. Okay. Now this relation gives a system of how many equations? N minus 1. N minus 1 linear equations. System of n minus 1 linear equations in how many unknowns totally? N plus 1 unknowns. N plus 1 unknowns. What are the unknowns here? m0, m1 up to mn. The additional two conditions. The additional conditions required are the natural additional conditions. The additional conditions required are the, what are the natural conditions? Natural spline conditions. Natural spline conditions. What are the conditions? I have told you. The second derivative at first point, second derivative at the end point, both must be 0. Both must be 0. Okay. These equations are solved for. So solve the system. So solve the system 11 for what are the values? m1, m2 and so on, mn minus 1. Solve the system n minus 1 and substitute these values in equation 7. Substitute these values in equation 7 for cubic spline. Okay, this is the derivation completely. And if, for example, if this is, we have taken space h, when if data is equispaced, that is hi equal to hi plus 1 equal to h, and for equispaced data already told you xi equal to x0 plus ih. Okay, then the spline in the interval, xi minus 1 to xi given in equation 7, and the relation between second derivatives, that means m's second derivatives given in 11, simplify as now. This is for equispaced data, cubic spline. Fix equal to 1 by 6h xi minus x whole cube mi minus 1 plus x minus xi minus 1 whole cube mi plus xi minus x by h fi minus 1 minus h square by 6 mi minus 1 plus x minus xi minus 1 by h. Just in place of hi write h square by 6 mi is what is the cubic polynomial. Cubic spline is the cubic spline. And what is the relation among m's? And 11 becomes, and equation 11 becomes, this is 7. Okay, and equation 11 becomes, what is simply, it is mi minus 1 plus 4mi plus mi plus 1 equal to 6 by h square fi plus 1 minus 2 fi plus fi minus 1. This is for I equal to 1 to n minus 1. I equal to 1 to n minus 1. Okay, this is the polynomial. And this is in what interval? This is cubic spline interval in what? In xi minus 1 to xi. Remember this. Remember, this is the cubic polynomial expression. And to get m values, you have to remember this one. This is entirely spline and cubic spline.